And I'm just going to mute you, HP, so we don't get any background noise, if that's okay.
Yes, yes, absolutely.
Okay, I begin, I guess. Right. Welcome to New Perspectives in Integral Life, held by Sri Aurobindo Integral Life Center, Fountain Inn, USA and Surat, India, in collaboration with our university. I am joined with my colleagues, Executive Director of Sri Aurobindo Integral Life Center, Radhe, and Chancellor of our university, H.P. Rama. And today we are very happy to have with us Ulrich Mohrhoff, who is a member of Sri Aurobindo Ashram in Pondicherry and who has taught a philosophically oriented course of quantum mechanics at Sri Aurobindo Ashram, Sri Aurobindo International Center of Education for several years. He is working in the archives, and he has published numerous research papers in Journal of Consciousness Studies, Foundations of Physics, Foundations of Science, International Journal of Quantum Information, etc. As well as a textbook, which is called The World According to Quantum Mechanics, Why the Laws of Physics Make Perfect Sense After All. And this it was published again in the second edition in 2018. He has also his own page, web page, which is called Auro Cafe, where he publishes his research, which you are welcome to visit. Today we shall have a deeper look into a connection between consciousness and quantum mechanics. So without further ado, I would ask you, Ulrich, to address the audience. Please, Ulrich.
So welcome everybody, and good morning in the US and good evening in India. Talking accurately about quantum mechanics is a great challenge. You can do it mathematically, but that's not what you're expecting right now. And you do it philosophically, but even there you have to go into modes of thinking and concepts that are very, very far from what one is normally thinking about. So that also is a bit abstract and difficult. And for me, there are two ways to proceed. One is I could ramble on, and the subject is so vast, I don't know where I would end up. So I've instead chosen to provide a little script and to go through it with you. I will also share a screen on which I'm showing the highlights and you should right now, I don't know, can anybody give me a feedback if you can see a blank screen right now on which I will project a few passages from what I'm talking about here.
Yes, we see.
So let me start. Science today is challenged from two sides. On one side, you have the deniers of climate science and other data-driven sciences. And on the other side, you have those like myself who are up against claims and beliefs to the effect that science, especially physical science, is the royal road to metaphysical truth. Such claims and beliefs are motivated by what the philosopher Thomas Nagel has called the bizarre view that we, at this point in history, are in possession of the basic forms of understanding needed to comprehend almost anything. Just a second, I want to blend in that screen. just, where am I? This is not working as it should. I'm sorry for that. How is that not working? Let me try this one. Okay, this is not in the right place. Okay, so here's the quotation. Now I'm going to continue. Because there is no rational explanation for the existence of consciousness in what appears to be a material world, this bizarre view leads to reductionism with respect to conscious experience. This is most obvious in two fields, the philosophy of mind and the philosophy of science. Physical science provides us with calculational tools. Sorry, I'm still having a little problem with my computer. Okay, in pre-quantum physics, it's impossible to transmogrify certain calculational tools into genuine physical entities or processes. One could pretend, for example, that the electromagnetic field not only serves to calculate the effects that charges have on charges, but also to describe the process by which charges act on charges. I'm sorry, this is not working as it should. In quantum physics, this sleight of hand no longer works. Quantum mechanics correlates measurement outcomes. This means,
We see only we see only too many hypotheses by the.
Yeah, I know, but somehow my cursor doesn't work properly. So I'm having here.
Maybe you roll.
It's my own text to which I refer that keeps jumping about crazily. So the electromagnetic field, but also in quantum physics, I just said this sleight of hand no longer works. Let me see if this. Okay, so this means that quantum mechanics provides us with tools for assigning probabilities to the possible outcomes of any measurement that one can make or that can be made on the basis of information derived from the outcomes of other measurements that have been made. So you have to note the central role played by measurements. I mean, measurements performed on quantum physical systems such as atoms and subatomic particles. The most important calculational tools is the so-called state vector, aka the wave function. If this is understood, let me just go to the next, here we have it. If this is understood as representing a physical state of some kind, its dependence on time is that of something that changes with time. The wave function then depends on time in two distinct ways. It changes continuously between measurements, and it changes discontinuously when a measurement is made. This leads to the infamous quantum mechanical measurement problem. What is it that causes the wave function to depart from its normal continuous mode of change? Ever since quantum mechanics appeared on the scene, it has been argued by some that what collapses the wave function is the consciousness of an observer becoming aware of a measurement outcome. I do refer to this tradition as quantum mechanics and consciousness 1.0. If you do not want to go down this rabbit hole, you will have to think of the wave function as a calculational tool, and you will have to think of its time dependence as a dependence on the time of a measurement, the measurement to the possible outcomes of which it serves to assign probabilities. So here's a nice definition, if I can show it to you, of the phrase going down the rabbit hole. If you think of the wave function as a calculational tool, you will be faced with a different slew of problems, foremost of which is the question, what exactly is a measurement outcome? According to a new and most promising way of thinking about quantum mechanics, a measurement outcome is a conscious experience. Let me just go down this here. Now this is a bit faster than I want. Yeah, a measurement outcome is a conscious experience. It is not something that happens in an independently existing external world and somehow enters my consciousness. It is something that happens in my consciousness, but which I'm able to represent to myself and others as an objective event. This approach is what I call quantum mechanics and consciousness 2.0. To be able to properly understand it, we need to know something about Niels Bohr, and to properly understand Bohr, we need to know something about Emmanuel Kant. So let me get him here. That is not, again, few words about Emmanuel Kant, the great German philosopher. To Kant, objective knowledge was a knowledge of objects. To be in possession of such knowledge, he argued, the experiencing subject must be able to organize its sense impressions into a system of objects that obey certain general physical laws. What Bohr added to Kant's philosophy of science was his insight that empirical knowledge was, let me show it to you. Empirical knowledge was not necessarily a knowledge of sense impressions organized into objects. It could also be a knowledge of statistical correlations between the outcomes indicated by measurement apparatuses. Quantum mechanics is this kind of knowledge. While the knowledge of the measurement apparatus remains a knowledge of sense impressions organized into objects, the correlations between the outcomes indicated by measurement apparatuses do not allow themselves to be understood in terms of sense impressions organized into objects. For the present-day physicist, it is not easy to understand the bewilderment that the founders of quantum mechanics experienced in the early days of the theory. Here's how the quantum revolution was described by David Mermin. Coming down, here we have the text. All the verities of the preceding 2 centuries, held by physicists and ordinary people alike, simply fell apart, collapsed. We had to start all over again, and we came up with something that worked just beautifully, but was so strange that nobody had any idea what it meant except Bohr, and practically nobody could understand him. So naturally, we kept probing further, getting to smaller and smaller length scales, waiting for the next revolution to shed some light on the meaning of the old one. That revolution never came. Quantum mechanics works as beautifully in the nucleus as it does in the atom, and it works as beautiful in the proton as it does in the nucleus, 7 or 8 orders of magnitudes below the level for which it was designed. It also works beautifully many orders of magnitude above that level, as for example, in a superconductor. In pre-quantum physics, it was assumed that measurements simply reveal independently existing properties. That means these properties exist whether or not they are being measured. The statistical correlations between measurement outcomes as described by quantum mechanics make this assumption untenable. This implies, now let us look if we can get to the next screen here. This implies, okay, that the properties of quantum systems and ultimately the systems themselves are contextual. This is an absolutely central and important concept, contextuality. Because the properties of quantum systems are defined by the experimental conditions under which they are observed. And they only exist if they are observed. So the click of a counter, for instance, does not simply indicate the presence of some object inside the region monitored by the counter. Instead, the counter defines a region and the click constitutes the presence of some object inside it. Without the click, nothing is there. And without the counter, there is no there. Until quantum mechanics came along, physicists could go about their business as if the external world existed independently of the conscious subjects by whom it was perceived. Next screen. Okay, this should be it. But if atoms and subatomic particles owe their properties to the experimental contexts in which they are observed, then the experimental apparatus cannot owe its properties to the atoms and subatomic particles of which it is normally said to be composed. And this means that neither microscopic objects like atoms and subatomic particles, nor macroscopic objects like the experimental apparatus can lay claim to an existence independent of consciousness. Macroscopic objects exist in our experience, and they exist objectively because our respective experiences agree to a certain extent. This agreement has often been explained by postulating a real world of objects which are the causes of sense impressions and which produce roughly the same impressions on everybody. Instead of explaining what it purports to explain, this postulate merely creates another conundrum. For while we can compare our respective experiences by talking to each other, we have no way of comparing our sense impressions with the objects that are invoked to cause them. By implying that the properties of the so-called microscopic constituents of macroscopic objects are contextual, that they are defined by macroscopic objects and only exist if their presence is indicated by macroscopic objects, quantum mechanics has once and for all disposed of that postulate. The quantum mechanical correlations between measurement outcomes tell an altogether different story, a different and more exciting story. Well, to get to know this story, I invite you to check out my newsletter, which you will find at this address. You can subscribe to this newsletter and you will get once a week or a little less frequently, you get a little essay about a subject relating to consciousness, to physics, and more generally to the philosophy of Sri Aurobindo. And you can also just, there's an archive where you can check out all the newsletters that I have sent out in the past. I now return to the two fields I mentioned initially, the philosophy of mind and the philosophy of science, especially physical science. The fact that interpreting quantum mechanics has become a major industry within the philosophy of physics mirrors the explosion of interest in consciousness studies since the 1990s. In both fields, a high priority is placed on providing reductionist accounts of conscious experience. In the philosophy of physics, the goal is to portray the experienced world as emergent from a reified probability calculus. And in the philosophy of mind, the goal is to portray conscious experience as emergent from neural firing patterns in brains. Both efforts are attempts to flog a dead horse. In the philosophy of mind, this is rather more easily seen. One merely has to take into account that neural firing patterns, insofar as they are known to us, are themselves experiences, and experiences cannot give rise to experience. So this is basically the end of my prepared text. Now I'm welcome. You are welcome to answer questions. I could talk a little bit more about quantum mechanics in the rambling mode. But first, are there any questions? Have any questions come up? You're maybe a little steamrolled by all the philosophy, which is, well, would have to say the same thing, perhaps a little more slowly. And if you sign up to my newsletter, you will get this text a little more elaborated, I suppose, in my next mailing.
Shall we stop the projection, maybe, and that we can see?
Yes, yes.
Okay.
Except maybe not, because there is something else which, okay, for the moment, how do you say stop?
You can
I
do,
want to
yeah,
stop sharing.
I already did.
You can stop sharing it for everybody, or?
Yes.
Okay.
Yeah, we're good to go. Yeah.
Yeah, so this is something on that screen that I could share later, which
You can
might be
always start
interesting to
again.
talk about, yes.
And you also
Questions?
have a couple questions there.
Right.
Okay.
First, I wanted to just to say thank you for this very interesting, deep diving deep into the matter as the enterprise of the consciousness. And what struck me that actually your definition is very close to the Derrida's definition of sign in the linguistics, because the sign in the linguistics has both two components, signified and signifier, which was actually discovered from the beginning of time, from the time of Bhartrihari, and his Vakyapadiya, Vachya and Vachaka. So on one side we have signified, which is being signified by the word, and on the other side we have a signifier, which is signifying the signified, and these two together constitute the word. So, and Derrida says that signified is never there and signifier is never that. And here we have very close to your definition of quantum mechanics, that on one side it is never there and on the other side it's never that, and put together they constitute the reality. So
okay, okay, I wouldn't agree with that they constitute. There's a lot more to reality than that. Reality can't be so simply summed up into or cut apart into components like signifier and signified. I don't think
from
so.
the point of view of consciousness, it's the very interesting operation between time and space, or between the which combined together creates the possibility of revealing them in manifestation, what we call matter, because matter is a very dubious term altogether.
That is very true. It should definitely be banned from the vocabulary of philosophy.
Right. So we look at the matter as somebody asked Sri Aurobindo. I wanted to provoke this kind of discussion, and maybe there will be more interesting questions coming on this ground. Something like Sri Aurobindo was asked, where is that, a vital or mental component within the matter? We didn't see it there. So we see the...
Well, it isn't there because matter is in our consciousness. Our consciousness is not in matter.
Absolutely.
It is an objectified construct of the mind. We objectify it. It's objective because we can talk about it. No, we can agree that we have the same experiences, but that doesn't change the fact that it's just experiences.
Yes. And you know what he answered? It's quite interesting. He said it's in the relation between the particles.
Oh, yes. This is something extremely fascinating, because the mother in the agenda once mentioned that there is only one thing. And everything is relations between that one thing and itself, So this is very central to my understanding of let us say, the reality beyond quantum mechanics, the reality to which quantum mechanics belongs. You know, quantum mechanics doesn't capture reality. It's just a small corner, basically, of reality. But it is an important indicator of what's actually going on. I haven't said anything about that. I just gave a little bit of an argument about the difference between quantum mechanics and consciousness 1.0, where people think of the wave function as a state, an objective physical state that evolves and then it changes normally continuously, and when a measurement is made, it discontinuously, and then you go down the rabbit hole. And so in consciousness 2.0, you see the world, or actually, well, it's a reversal, you know, in having this absurd idea that reality is represented by a probability calculus, and then trying to get out of that sort of reality conscious experience. That is totally doesn't work. But you can invoke conscious experiences then as a second kind of reality, and sometimes it pokes into that reality and extracts some measurement outcomes. So that's the ridiculous view, which is known as, which I call, quantum mechanics and consciousness 1.0. So in 2.0, the reality is in consciousness and is objectified by us. You know, I have already discussed these themes very intensively in a number of my Substack mailings. So I really invite you to go to that orocafe.substack.com website and check out. By the way, right now I saw somebody asking a question. It just flickered across my screen relating to the famous, or should I say infamous wave particle duality. Did you see that, or did I only see that, or did I imagine that?
No, there are five questions here. You could see them on the screen, so you could
No,
just.
I don't see anything.
Oh, you can click on
now.
question and answers.
The Q&A there.
Q&A.
Oh, yeah. Okay. Oh, that's all right.
How does quantum physics sees free will? First question for you.
It doesn't see it at all, because it describes the inanimate world. It makes us, gives us some idea, some understanding of the reality we construct in our minds and objectify, so that we can treat it as an objective reality. But it does not absolutely enter into the subject of, for example, of life. And, you know, free will certainly doesn't come up before you have life, you know. We're just talking about these kind of stable structures that in our experience we tend to refer to as matter. You know, that is, quantum mechanics is concerned with that. In my own philosophy, or philosophical understanding of things, in which quantum mechanics has a place, I would have to say, but then that's basically what Sri Aurobindo is saying. So you would be much better advised to read Sri Aurobindo on the subject.
There are several questions here. Can consciousness exist without experience, unembodied? Is there reality in the atom?
Quickly, I do not. Of course, these are two words. Consciousness itself can be understood or defined in so many ways. And experience, again, is used in so many different senses. So I think it would require quite a long discussion to first settle on what we mean by each term, and then discuss the relation between these terms, you know. So no, when I use it, I speak of conscious experience, because I don't know how there can be unconscious experiences, but psychologists talk about that. To me, it seems to be a contradiction in terms.
There is another question. I am new to your teachings. What are the practical applications of what you are saying regarding illness?
Vladimir, this is far beyond the domain with which I'm concerned here. I'm not talking about, I just said, I'm not talking about life, so I'm not talking about the living body. You don't have an illness without having a living body, don't you?
Right, right. But yeah, if we could imagine what it has, the fundamental physics has all the answers to all our kind of existence in a way. If we could really see what is happening on the level of the embodied, consciousness, and see this universe as an enterprise. Well, I want to ask you something which I just recently saw, that there are new theories of physics, and one of the theories is coming up. It's a very totally new, that there are not many electrons, but one electron for all. This is something unexpected.
Unexpected?
Well, unexpected in a way that
But not unexpected by any physicist.
Right, right. But what do you say about this? That there is one field which holds all the other expressions.
No, I just mentioned the idea which I like very much, which you touched upon, and I referred to Mother mention it in the agenda, that ultimately there's only one thing, one reality. You can call it as in Sanskrit, they called it tat, meaning that. That one, tat ekam, that one reality, aka Brahman, aka Satchidananda, and so on and so on. One thing. But how does that one thing manifest the world? Now, when it comes to the physical world, quantum mechanics has something to say about it. How does that one manifest the physical world? It doesn't manifest the physical world in a vacuum, and it creates it out of itself by entering into self-relations, reflexive relations. So when you have, for example, a particle here and a particle there, then what you have is that same one reality twice, once here and once there, made to look as two particles because a spatial relation exists between them. So it is the spatial relation, which means the distance, no, the spatial separation, the relative positions between the two, that makes that one thing to appear two things. And so all the forms of all the beasts and baubles in this world are manifested out of the relations of this one thing with itself, self-relations.
Interesting.
So that is something that jumps out of quantum mechanics itself. And again, if you follow my newsletter, you will get to learn all about these things.
And you know what your definition is about self-reflection reminds me of Sri Aurobindo's definition of essential sense in the Upanishads, where he says that reality perceives itself in such a way disconnects its self-knowledge from its own self-power, as it were, and takes it into itself again anew, as if it never knew it. And that creates the essential sense, the consciousness, actually. Consciousness which participates in power disconnects from that workings of power to perceive that working as if it never knew it before. And that is the definition of the essential sense.
Well, but in a way, the Sankhya way of looking at reality First of all, when I say that the world is a manifestation of that one reality to itself, I didn't finish my sentence. I said it wasn't a manifestation in some sort of vacuum. It was a manifestation to itself, which is to say, in its own consciousness, you know. And now there are different levels of consciousness. There are different levels of reality, because there are different ways in which that reality manifests or presents itself to itself, you know. And when you come, this is actually what you were talking about is actually very close to what Sri Aurobindo discusses in one chapter of The Life Divine, about how we get down from the supramental awareness of reality to the mental awareness of reality. And that is just the creation of that separation, because in the supramental reality, knowing is being. You know, you can't separate the two. What you know, that is what you are. And if you know something, you are it. And you are something, you know it. It's one and the same thing. And when you come down to mind, through overmind, and several levels of consciousness, the two grow increasingly separate. But you can say that the whole of reality is implicit in the original consciousness at the highest level. Whereas when you go down completely into the involution, into the inconscience, then you have only that and the relations are lost. And when it gets back to creating relations with itself, self-relations, which at first are only kind of space relations, spatial relations that may change with time, which is to say, which is a material reality. That is the first thing to come into being after the full involution. You then start with just what we call atoms and subatomic particles. I mean, first with subatomic particles, and then later atoms form and galaxies form, and you have an evolving universe. That is happening once the stage for the adventure of evolution has been set, and which is a process of involution, where all the powers of being, of reality, of that are involved. In that alone is there, but its powers are no longer in evidence. So that seems now to appear to be no thing, nothing. And then wham, boom, Big Bang, and evolution starts for the fun of the thing.
Yeah, nice. Yeah, makes sense. If we follow that oneness of consciousness, constantly viewing how it projected itself, to know itself in detail, as Mother describes, yes. There are questions here. Shall I read some of them to you?
Yes, yeah.
In essence, consciousness 2.0, all the reality, matter, etc., is mental experience that he can objectively, as external events, laws, when we are conscious, aware of them, and can describe in words or math. This is the question mark at the end. Doesn't when we are conscious, most probably, I just don't see the question here. So in the essence, consciousness 2.
No, it's the subject is quantum mechanics and consciousness 2.0. That is a different way of talking about the relations between quantum mechanics and consciousness than the 1.0, which is which was started very much at the beginning when quantum mechanics came on the scene. There was von Neumann, there London and Bauer, Wigner, and the various other characters were then saying, you know, this collapse of the wave function, this change in the evolution of the state vector, or, which happens when an observer becomes aware of the outcome of a measurement, that implies that somehow the observer is essential to consciousness. But the wrong idea was that reality was thought of as, first of all, represented by the wave function, which is silly enough, but then consciousness was invoked as something separately existing and somehow influencing the otherwise continuous evolution of reality in the form of the wave function. So anyhow, this idea was later totally rejected by the vast majority of physicists who think about these philosophical matters. By the way, it's only a small number of physicists that actually think a little deeply about these philosophical issues, because most of them are so fed up with all the nonsense that has been produced in attempting to make sense of quantum mechanics that I understand them very well, that they don't like to hear about it. So this new relation, this new understanding of the relation between consciousness and quantum mechanics, that actually goes by the name of Cubism. And it has started at the beginning of this present century, and the first papers came out in about 2000, 2001, 2002. It's called Cubism, which started out as quantum Bayesianism. So Bayesianism is an understanding of probability, you know, and so of course probability is central to quantum mechanics, and so this was then a generalized quantum theory of probability. It has later rebranded itself as Cubism, and David Mermin is a very well-known physicist and a good friend of mine, who says that he likes the term because Cubism is actually so different from previous traditional conventional ways of thinking about reality as Cubism, the other kind of Cubism in art, was different from previous forms of art. So Cubism actually not just a way of understanding quantum mechanics, but a more general way of understanding science. But it has so far been worked out only in relation, really substantially worked out in relation to quantum mechanics. This Cubist, I have a long discussion with the founders of this Cubism over many years, trying and sometimes even succeeding in making them understand that, you know, these people oppose the views of Bohr like so many other physicists do. But this is basically because they totally do not understand Bohr. So I've recently written also a paper, was recently published in also a respectable journal on quantum mechanics and foundations. How do I say this? That Bohr, I've pointed out to them because the reason they reject Bohr is because they misunderstand him so completely, like almost anybody else. And I've shown that what Cubism is now saying is actually much the same thing that Bohr himself had been trying to say long ago, you know. So I find it a very, very welcome return to a deeper understanding that was lost, because of course it puts consciousness at the center of reality, And well, I see academic circles cannot stomach this kind of thing. So there, the name of the game is to explain everything else, everything in materialistic terms, whatever that means, and they come up with enormous amounts of nonsense.
Basically, as I understand from that, what we read from quotation from Bohr, that the context defines actually the presentation of consciousness. Basically, in every context, the consciousness will choose or will present
no,
itself.
you have to understand context here, as it is. These are all rigorous terms, rigorously defined terms within quantum mechanics. So it is the fact, the context is the measurement apparatus or the experimental setup in the context of which something is observed. And what you observe in this experimental context depends on the experimental context. It is not something that exists in itself outside of an experimental context. It doesn't exist. The experimental context creates, not totally, but to a large extent, what you observe. So when you then find that the property of those so-called constituents of macroscopic objects are in fact depending for their existence on the macroscopic objects by which they are observed, you have a beautiful circle, a circle that stays inside your consciousness. It doesn't go out anymore into some unknown reality that somehow is represented in our consciousness. There is reality only exists in consciousness. The big difference is that there are different kinds of consciousness, different relations between subject and object, between that and how it manifests itself to itself, you know? So there we have, and we are evolving out of an involution where life and mind, which are certain powers, ways of manifesting itself, ways of acting, were initially involved. So not in evidence, apparently non-existent. They are slowly come into being. They were always there, but they were not manifest. So they are manifesting themselves now, gradually. And there's much more to come. No? Life and mind is not the end of the story.
It's interesting. I may make a parallel before we continue with the questions which are waiting here. The parallel between linguistics, because I'm coming from the linguistic background, and the difference between the speech which defines, which is the action of consciousness, and the language which this speech chooses to express consciousness. And the language becomes the context in which it can express itself, so to say. And it may generate a new language, it may create a new tools within the context, but it is using something which is already given as you said, the set of tools by which it is measured. It's very rigorous and very precise in a way, and still it can create a new context. As in the Vedas they say.
You see, in the radically revolutionary new situation that arose with quantum mechanics is precisely that the one context which always existed fell apart, broke apart into pieces. The one context which was the context for classical physics is human experience. We experience things, we conceptualize things, we create theories, we create models, but it's all in human consciousness as the one universal context in which scientific understanding operates, especially physical science.
Mhm.
Now, suddenly, that context broke apart because certain experiences, certain setups, which are also experiences, made it possible to have a certain kind of experiences which were depending on one kind of setup or experimental context, and you create a different experimental context, it allows you to have a different sort of experiences. Now, you see, before quantum mechanics, all these different experiences, they could be integrated into one reality. And now this one reality broke apart because a certain aspect of the behavior of things are dependent or realizable or observable only in one experimental context, and other aspects of the atoms or subatomic systems are observable or realized only in or by a different experimental context. So no reality in itself could be created anymore out of this. It is all only depending on what we experience, how we set up the possibilities of experience.
Mhm. Mhm. There is an interesting question here which may continue the same line of thinking. Gives the wave-particle dualism an explanation of embodied consciousness? Again, it belongs to the previous system, which is collapsing now, the context which you are mentioning, but still, wave-particle dualism. Can
Now
you
you see
address this?
on my Substack newsletter, when you go to the archives, there is one mailing that is called the most beautiful experiment in physics. That is the famous two slit experiments where electrons are made to pass through a wall with two slits, and then one observes how they are detected, the statistical distribution, how they are detected at the backdrop, at the screen. I have it here on my computer. I don't know. Let me see if I can perhaps share it. Where are we here? This one. Let's see. How does it work?
Yeah.
If I share this.
Yeah, we can see it.
You see, this is the item which is known the most beautiful experiment in physics. So here's the setup of the experiment described, a little explained. So if you see, this is totally a question of two experimental setups. In one setup, you can know through which slit each individual electron went. So you get two humps. One hump is the statistical distribution of the electrons that went to the left slit, and the other hump, the electrons that went to the right slit. And if you add up the two humps, you get one hump that is a solid line in this graph. Now look at this one. This is how the electrons at the backdrop are distributed in a different experimental context when it is not possible at all to figure out in any way how which particular slit each individual electron took. So a different prediction. And then you have here an experimental finding. Here's somebody who has sent electrons one at a time, recorded where they land on the backdrop. And you have first 100 recordings, doesn't look like anything. Then 3,000 recordings, begins to look like something. Then 20,000, then 70,000. And suddenly you see you getting an approximation to the quantum mechanically predicted distribution of electron detections at the backdrop. So the usual way of talking is, in one experimental context, the electron behaves in a way like a particle. In another experimental context, it behaves in a way like a wave. Now, what I want to emphasize is that when people say the electron by itself behaves sometimes this way and behaves sometimes that way, this is utter nonsense. The electron has no behavior of its own. The way the electron behaves depends on the experimental conditions under which it is observed.
Mm-hmm.
If it is observed under these conditions, it behaves sort of like a particle. If it is observed under the other conditions, it behaves sort of like a wave. It is not in itself either this or that. These are behaviors that are elicited by different experimental contexts.
Thank you for explaining this. This is a very important part which confuses many people. Yes, thank you.
Yeah, that's why I keep emphasizing the contextuality. That is so important, that all the properties in the atomic and subatomic domain depend on how we in our laboratories observe them.
Yeah, great. There are more questions here about Pralaya, about Carl Jung, about other. Let me start from. There are 11 questions for you. Maybe not all of them you can answer, but you can touch upon some of them. Can consciousness exist unembodied? We already spoke about it. Can you comment on Arthur Schopenhauer, who characterizes the phenomenal world as the product of a blind and insatiable nominal will? Agni.
Well, you know, it's the state very close to the total involution of consciousness, where where you have a first emergence, where the stage is being set for the adventure of evolution, where you have not yet life, you have not yet mind. There, of course, the force that works in the world in this particular way, in this particular scenario, very close to the beginning of evolution, that force is always a form of will, which is always an aspect of consciousness, always. It is its most involved, its most reduced form. So I totally agree with describing the working of this force at the level of inanimate matter as a blind will. I would also concur with describing it when this will suddenly emerges in life as a sort of self-determining force that, you know, you get living organisms that have their own behavior and are sort of driven by a will, no longer by a purely mechanical force. When that happens, which is to say life evolves, you can very well describe this will as insatiable. It can't get enough of life. But then that's only one stage. Afterwards, a more intelligent will evolves. Afterwards, a more loving, emotional will evolves, and so on. Oh, I should say the emotional comes before the intelligent, perhaps. I'm not so sure.
Interesting. And what? How can you comment on the law of preservation of energy? This is a very fascinating law.
It's a very
ancient story?
Yeah, again, you see, these things are always quite elaborate if you want to explain them properly.
Mm.
Because we have before us a task of introducing a metric, which is to say a way of measuring space, the way of measuring distances. We also need a metric for time, then, as a way of measuring durations. And in relativistic physics, it becomes a more sophisticated way of measuring space-times intervals, which have a time component and a space component. But the metric is not built into space. The metric is something that we create and we choose it. In fact, even Newton was aware that we choose the metric that with which we want to describe the behavior of physical objects. You see, there is not a given metric and then the behavior of physical objects. To describe the behavior of physical objects, you need a metric. And you can describe it in a clumsy way with an inappropriate metric, and you can describe it in an elegant way with an appropriate metric. So that's why Poincaré was the guy who first insisted that one geometry, it's another word for metric, is not more true than another. It can only be more convenient. You choose the metric that is most convenient to describe the behavior of particles and other material objects. So, let me just one or two more sentences to conclude this argument. When you have a freely moving body in classical physics, the most convenient way to describe it is that it moves along a straight line at a uniform speed. You can introduce a metric where it behaves in silly ways, but that's not convenient. If it's a freely moving object, you describe its properties in the most simple and elegant way. So in this particular context, you have introduced what is known as the homogeneity of space and the homogeneity of time. Homogeneity of space means it moves equal distances in equal time intervals. And homogeneity of time is that one time interval, say 1 second, is physically equivalent to another second later on. And if you introduce a time coordinate in this convenient, elegant, and simple way, that implies the existence of a physical quantity that is conserved. And if you do the same thing with space, that implies another physical quantity that is conserved because of the homogeneity of space, which you have introduced for the sake of convenience. And the quantity whose existence is implied by the simplest choice of a time coordinate, that quantity is known as energy. And the quantities whose existence is implied by, or rather whose conservation and therefore its existence, a quantity that is not conserved isn't very important in physics. That quantity which is conserved on account of the homogeneity of space, that is what we call momentum. So these are abstract definitions which mingle mathematics with philosophy, with how we construct concepts. There's an intermingling on conceptual thinking and mathematics. So in that case, the conservation of energy is not an empirical finding. It is a simple consequence of the fact that we have chosen our time coordinate in an intelligent way.
Fascinating, really. One can see how consciousness is
You see,
present.
the whole thing depends on us, on what we do in our minds, what we construct.
Yeah, yeah, beautiful. Yeah, there are a few more questions here. I do not know whether we will be able to answer all of them or to touch upon all of them since our time is over, but maybe some of them about is there parallel and what is the parallel between Cubist science and art? You were just mentioning.
No. Cubism is a way of looking at science. You know, the parallel here that Mermin invoked was simply that the departure of Cubism from previous ways of thinking in science is as radical as the departure of Cubism in art from previous ways of doing painting.
I understand. Does Big Bang correspond to Pralaya in some way?
No, it's the reverse. It's the beginning, not the end.
Yeah.
Or you can, of course, say that the
Pralaya was
beginning
there
is
before.
that the end is the beginning of another phase of manifestation. You know, okay, that's mythology. It's not my subject, really.
All right, great. Yes. Yeah, the question, do you have some printed works on the topic which could be read? You just mentioned, and here all the participants.
Look, I have this Substack newsletter, and I cordially invite you to look at the individual items which are in the archives and which I've already posted that will clarify many of the questions. Secondly, if you subscribe to this newsletter, you will get it once in a week or a little less frequently, and you get the opportunity to ask me questions and even suggest topics that you want me to discuss.
Wonderful. So other questions I will leave for you. I will send you the questions to, or you can address it through the cafe, through the, what do we call it?
Aro Cafe.
Aura Cafe, yes, sorry. Aura Cafe is a nice word. We have Aura University, we have Aura
So this
Cafe.
cafe is after you finish the university, you go to the cafe and
Right, discuss topics at your leisure time and with free mind. Wonderful. So thank you, Ulrich, very much for this beautiful exposition, very deeply reaching and integrating our physical reality into the spiritual, into the reality of consciousness, which we are looking forward to do in our lives, but we do not have tools, do not have yet mind. But this part we were always missing. We are speaking metaphysics, we are speaking about psychology, but physically to look at reality from this perspective is very unique and very rewarding. Thank you very much for this.
Thank you, all of you, for joining me, and thank you for having me with you.
So we hope we will continue our explorations further, and that many more people will come to our cafe, and we meet again and continue our explorations in this direction.
Okay.
All right.
Goodbye then, everybody.
Yeah.
Thank you.
Namaste.
Thank you very much.